Now we can see our virtual machines booting up. The boot process itself, you should pay attention. Computers support two different types of boot modes today. There's legacy BIOS mode and then modern UEFI mode. The BIOS mode has not changed very much from the boot up process that PCs have used all the way back to the IBM 286 in the 1980s. But it's made obsolete and is no longer going to be supported as of 2020. It's being replaced with UEFI. So UEFI offers a lot of new functionality, including encryption support, technologies like Secure Boot, all sorts of fun stuff. I'll mention Secure Boot. It is a mechanism by which one can cryptographically sign their kernel, and that way they are using the kernel that they're using for their operating system and make the machine more secure, and it will help prevent third parties from tampering with your machine. It's sometimes important in business that, make sure your machine hasn't been tampered with, but it's an advanced topic that I'll save for a future course. Just be aware of it. You may want to disable it in your UEFI on your machine if you have the option. Windows can use Secure Boot because Windows' kernel is cryptographically signed. So it's possible to use Secure Boot with Linux, in case you are wondering, but like everything, it's a bit of a DIY solution. So you've got your BIOS and you've got your UEFI that takes you from the power off state to the power on state to some logos on the screen. And what about inside the virtual machine? Well, yes, it's got a BIOS or UEFI in that case. On Fedora 25, I've got UEFI. When we're using VirtualBox, it's the old legacy BIOS boot mode because you don't need anything else. So even in virtualization, there's still a step that happens with the BIOS or the UEFI that takes you from a machine that's turned off to a machine that's on and running and ready to, do stuff. So the UEFI hands off to something called a bootloader. That's Grub2 in our case on all three of these Linux distributions that we're looking at. Are there other bootloaders other than Grub2? You bet. One of the other ones that I'll mention is REFIND. Refined? I don't know how you're supposed to pronounce it. It's by Roderick Smith. And this is another great one that's good to use in situations where you want Secure Boot and some other advanced EFI features. Some machines, like the Microsoft Surface tablet, for example, are EFI only, and so REFIND is a much better choice when using it with those systems as opposed to Grub2. So the bootloader is an incredibly important piece of software. Every OS has a bootloader of some kind, or at least a bootloading process. And so we get a little bit more into the mechanics of EFI booting and the file system handoff and that sort of thing in the advanced course. But for now, the question is, how do we go from the peripherals are just on and initialized to giving the Linux kernel control of the system? The answer is the bootloader. It is responsible for loading the Linux kernel, and that's what Grub2 does. Remember our discussions about the Linux kernel and microkernels and monolithic kernels? It's all very applicable here. Grub2 can also present us with a menu, for example, of different kernel versions or of crash recovery and of standard boot modes. So this is Grub2. That's what we're looking at. We can hit E and edit the parameters in here. There's a lot in here. More than you really need to worry about for this introductory course, but I want to show you these two lines specifically. Hit E. I've arrowed down to the bottom, and now we're looking at a Linux line. And then we've got an Echo line and a initRD. So we see Echo loading Linux 4.9 blah blah blah, and then we see Linux, and then we see Echo loading initial RAM disk, and then we see initRD. So remember when we were doing the installation and there were terms like bootloader and initRD and all this stuff flying around. What the heck is that? Well, the Linux line is the kernel. It's the kernel itself. And so we can see that it's saying, hey, Linux is found here. So that's a message to Grub to say, hey, Grub, you're responsible for finding and loading the kernel and doing some of this other stuff. And you can kind of read some of the stuff before this in the config. But again, it's kind of an advanced topic. The only things that really matter here are that Linux line and the initial RAM disk line. So the Linux line is /boot/vm linus-4.9 blah blah blah. It's Linux with a Z. The Z implies compression. It's a compressed kernel image. That's why that is the way that is. And then you've got root equal and then some gobbledygook and then read only and quiet. So root equals and UUID is a unique ID of the disk, and that doesn't necessarily have to be a unique ID of the disk. That might be a path to find a disk on the system or anything like that. In this case, the FD51 blah 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 is no doubt going to be different on your system. That's basically the fingerprint of the disk. It's unique. So if you were to take that hard drive out and plug it in somewhere else. If this was a physical computer, that UUID is going to be the same, whereas where the device is in the system might change. And so you can specify, hey, the root file system is here, or somewhere else, or whatever, and that root file system is slash. That's what that is, and we're going to talk more about that a little bit later in the course. And then you have RO. What's RO? Well, that's a modifier to the root. That's telling it to mount it read-only. And so when it's read-only, it's going to go through and do some checks and make sure that everything's okay, and then it's going to remount that root partition, what will be slash, as read-write. And then quiet says, you don't have to display a whole bunch of messages. You can just boot up and have like the little progress indicator or whatever. So we're actually going to get rid of quiet. Now initRD says /boot/initrd.img, blah, blah, blah. What's the initial RAM disk? What is the initRD? So it's a little bit of a chicken and egg problem. We talked about Linux, the Linux kernel, and how the Linux kernel is modular, so you can load modules and do stuff. Well, the Linux kernel being modular, how is the Linux kernel going to load those modules in when it first starts? I mean, the Linux kernel can understand your hard drive, it can understand your file system, but it may depend on modules to understand your file system or understand your hard drive or understand where it is in the system. It's not a guarantee. The initial RAM disk sort of solves that chicken and egg problem. The initial RAM disk contains all of the other stuff, all of the other kernel modules the kernel may need to load in order to boot into the boot process and actually be ready to boot up and run user programs. So when we booted the kernel, in all three cases, it basically booted straight to a login screen. And in order to get to the login screen, you have to load all the device drivers for all the hard drive and that kind of stuff too. But not just that, networking, video, the whole 9 yards. There's a lot of complicated stuff going on under the scenes. And so the initial RAM disk is what the kernel needs to bootstrap the system. So think about this big picture. You've got the UEFI or the BIOS. It hands off to the bootloader, which is a very small program, which is responsible for loading the Linux kernel. And it passes some configuration parameters to the Linux kernel through that Linux line. So the Linux kernel is loading, and then it needs to load some modules and things like that. Grub2 provides the initial RAM disk to the kernel so that the kernel can read data from the initial RAM disk, and it doesn't have to figure out how to mount your hard drives. You might have a really obscure situation with your root file system. It might be iSCSI, network-based, might be encrypted, you don't know. So the initial RAM disk really helps you out to have all of that stuff that you need to deal with whatever your particular situation is with your root file system. So that's what those lines are. So I'm going to jump down here to the quiet line, and I'm going to remove quiet. I just use the arrow keys and the delete key on the keyboard. Now I'm going to, it says Control X or F10 to boot. I'm just going to hit Control X. And now notice this boot up process is different looking than the boot up process that we were seeing before. So quiet hides all of those messages that you see from the kernel. Maybe you boot it up and it gets hung on a logo. You ever boot Windows and it just has a little spinny thing and it just hangs and it's like, what's going on? Well, this is like that. You can say remove quiet, and if the system hangs, you'll see what it hung on because it's going through all the different systems. And as we can see, the system still booted up normally and took me into this. This is kind of called a display manager. This is the GNOME Display Manager, GDM, and this is providing a login system. So if we look at this, there's some little details here. There's the little Debian logo at the bottom. Also got a little gear here. Like, what is this? Is System X11 default GNOME or GNOME Classic? What's going on here? What are the differences here? These are different options for signing into your actual system. And so System X11 default just means whatever the system default is, which in this case is GNOME, but you've also got the choice of logging in GNOME Classic. Now if we go back to our Red Hat virtual machine, see, it's the same thing. It looks similar. It's maybe not as graphical. I can hit E here as well for this. Now remember the Fedora or Red Hat Enterprise had the little lines going across the bottom. I'm just going to go down here and say it's Linux 16 and initRD 16. Now it's a little different syntax, just a little bit. And so this is dev mapper rel root, read only. And then look, crash kernel auto rd.lvm equal lv root. So Red Hat uses LVM by default, and we opted not to use that in Debian because it makes things overly complicated. It's like I knew. So I'm going to get rid of quiet here, language, see there's quite a bit more parameters on the Red Hat side of things, but we still have our Linux line and we still have our initial RAM disk line. So functionally, it's pretty much the same. We'll do Control X to start. A lot of the differences between these distributions, like I say, is by convention. So not really a lot of functional differences. So that was pretty quiet. Then we still got our little slidey lines across the bottom, even though I told it quiet, but we got a lot more informational messages than we did the first time around without the quiet being there, or with the quiet being there, which hid a lot of stuff. So now there's a couple more things about the boot menu that I'll mention really quickly. Every time you update your kernel, or every time the system downloads an update for the Linux kernel, the distribution is automatically going to update the initial RAM disk. The initial RAM disk, the drivers, the versions of the drivers go with the Linux kernel. So you can't at least it's a dangerous idea to update your kernel, but not the initial RAM disk. But the distributions all provide tools for automatically doing that. You should also be aware that it's possible to manipulate the kernel line and add more parameters to it, which can help you out of a tough spot if your system can't boot. You can boot it in single user mode. You can boot it by getting a command shell directly. By default, these distributions will try to be secure, and when you do single, it'll still make you enter the root password. But without encryption, it's still possible to bypass that. So just be aware that if your system is really, really hosed, you still can manipulate the boot line, the boot parameters there on your Linux line and pass things to the kernel to do things like disable security, provide an immediate shell or an immediate login, single user mode, which prevents a lot of services from starting up, which may be one of the problematic services that's preventing the system from booting. So something to keep in mind. This is something to really think about. I mean, really think through the boot process and understand how it's working and what all goes with it and that kind of thing for these three different distributions.